Okay, so the second problem from our notes today is, of course, going to be a little bit more difficult than we did yesterday. So I'm looking at this, I've got cosine plus sine squared over 1 plus cosine equals 1. Now, if you look at the notes that I gave you guys to take, step 1 is, of course, you work with the more difficult side, which is obviously the left. Then step 2 says do any kind of algebraic simplifications. And in bullet point 3, it specifically says if you see the denominator as 1 plus a trig function, it says to multiply by its conjugate and use a Pythagorean identity. So what are conjugates? Well, conjugates are when you have two things in the form like this. A plus b and a minus b, where the two terms a and b are the same, but they differ by sign. And when you FOIL that out, you get a squared minus b squared. It is your difference of two squares. Okay? And why would this be important? Well, because when you take 1 plus cosine and you multiply it by its conjugate, you're going to get a squared term, which is basically telling you, hey, you can use one of your Pythagorean identities. So when I see this bottom as 1 plus cosine, that's what I'm going to do. I'm going to multiply the top and the bottom by the conjugate of the bottom. So 1 plus cosine, that's a plus b times a minus b. When I do that, I get this. I get sine squared x times 1 minus cosine squared x, and I'll show you why I did not multiply that sine squared in yet. And on the bottom, you get this. Okay? Now, when you see squared terms, you should look at your Pythagorean identities, and especially the bottom now, I have 1 minus cosine squared. And when we look at our Pythagorean identities, that is sine squared. So I end up with sine squared x times 1 minus cosine x over sine squared x. So I change this right here to sine squared x. Now, sine squared x divided by sine squared x, I'm left with cosine x plus 1 minus cosine x. And cosine minus cosine is 0, which leaves us with 1. So that's one way of doing it, pretty simple way. Or I could have used that idea of conjugates, the Pythagorean identity and conjugates at the beginning, and instead of multiplying the top and the bottom by 1 minus cosine, what I could have done is changed my sine squared. I could have changed this to 1 minus cosine squared over 1 plus cosine. So what I did was I actually changed sine squared to its Pythagorean identity 1 minus cosine squared because it is a difference of two squares, which means it factors into its conjugates like this. And then this one will divide out with that one and leave us basically in the exact same place here. Minus, that's 0, leaves me with 1. Okay? So either way, you're going to have to use the Pythagorean identity. Now that's two ways. The third way, and probably the least popular way, would be to actually adding these two together and turning it into one term. And to do that, instead of multiplying the top and the bottom of that one, I'm going to multiply the top and the bottom of this one by 1 plus cosine to get common denominators. And then I can add the numerators together. So when I do that, I'm going to get cosine x plus cosine squared x, because this is going to distribute in, plus the sine squared x on the other one, all over 1 plus cosine x, like that. And just like the other problems, the other two solutions, the first thing I see is one of my Pythagorean identities. And this right here, this identity, cosine squared plus sine squared, that's 1. So that changes to 1, and then I end up with this. And since the numerator and the denominator are the same, I'm left with 1. So there are 3 different ways of doing this problem. Does it matter which way you do it, or which path you choose? Absolutely not. Some you're going to understand better than others. Okay? You choose your best path and make that decision for yourself. Okay? So any way you do it, it's all the same.